What is up, my friends? All right, we're going to go ahead and take a look at this test review, okay? I know there's a lot of questions. Just break it up one page at a time, all right? This test is going to be multiple choice. This is going to cover everything. Let's do it, shall we? Okay, number one. For some function, the derivative is 3t squared minus 4. T is greater than or equal to 0. If the function has a value of 0 equals negative 2, find the value at 3. All right, first thing, this is the integrals test. Guess what we're going to do? Take an integral. Okay? So when I integrate this, remember how this goes to t to the third over 3. Remember how 4 goes to 4t. And then I have a constant, okay? So when we do integrals, we're going to be doing plus a constant. Now, this piece of information right here is what allows me to find the constant, okay? So I'm going to say, okay, f of 0 means I'm plugging in 0 for t, and it should equal negative 2. So 0 plus 0 plus c equals negative 2, so c equals negative 2. All right? So that's not what it's asking me, obviously, so I got to keep going. Find the value of the function at 3. So let's go back to my f of t right here, and let's find out what f of 3 is. Okay, it's going to be 3 to the third minus 4 times 3 plus a constant. But instead of plus a constant, I know that the constant is negative 2. So it's going to be 27 minus 12 minus 2, which is 15 minus 2 is 13. Okay? All right, so for for number 1, I got A, which is 13. Okay? Awesome. Let's look at this next one. You guys need to get used to this. As soon as you see derivative, integral, like right next to each other, and you're like, this is crazy. What's going on here, right? This definitely is just your second fundamental theorem of calculus, the second FTC, which says that if I'm taking the derivative of an integral, right, they cancel each other out, and it just gives me this, but I have to put the x squared in it. Now, there's one other thing that you need to remember. Okay, so I put the x squared right there. The one thing that you do need to remember on this, though, is if you're plugging in something other than just a regular x, like a square root x, you got to do a chain rule. So I do need to multiply by the derivative of square root x. Hopefully you guys remember this from first semester, but the derivative of the square root of x is 1 over 2 square root x. Okay? The way I got that, in case you forgot, okay, I can rewrite this as 1/2. And so the derivative is 1/2 x to the negative 1/2, which is bringing that on the bottom, making it a square root. Okay? Let's see, right here, because it says square root of x squared, I don't know, a square root squared is just x. So that looks pretty good, and then I just need to find which one says 1 over 1 plus x, and then a 2 square root x on the bottom. That's going to be a. All right, cool. Number 3, this is not multiple choice. Everything on the test will be, just on the review. Some of them aren't multiple choice, okay? All right, so here's what we got. At time 1, there's 500 gallons of oil in a huge tank. It's leaking out at this rate. So anything that's happening over time, you guys, if it's happening over time, we're going to integrate it to find out how many gallons we actually lost, okay? It's kind of like this. This is how I think of it. If I have gallons per minute and I go backwards from that, that tells me the total gallons that I lost or gained or whatever, okay? If I had gallons per minute and I took a derivative of that, that would be gallons per minute squared, okay? Because that's like the acceleration. That's how fast the rate is changing of it going in. So try to kind of like make sense of that, I guess. Okay, so when it tells me this equation of the rate, if I can integrate that, I'll figure out how much oil I lost because it's leaking out. And I'm going until time equals 4. So what I want to do is I want to go ahead and integrate this 1 to 4. Okay, so from 1 to 4, I want to integrate 1 minus 30 square root t. I'm going to go ahead and write that as t to the 1/2. Okay. All right. The integral of 1 is t. The integral of t to the 1/2, right? You add 1 to that, okay? So it's going to be t to the 3/2 times 2/3. All right. Now, I would say plus a constant, except we're evaluating this from 1 to 4. So I don't actually need to put plus a constant. Or yeah, from 4 to 1. All right. Shoot. Okay, I'm going to actually simplify that a little bit. Okay, 3 goes into 30 10 times. So I got t minus 20 t to the 3/2. Okay, I'm going to evaluate this 4 to 1. Let me move it over here. All right. Actually, move it over here. Sorry, I try to give you guys enough room, but also try not to kill like 1,000 trees when I'm doing this. Okay, so now I'm going to do top minus bottom, okay? I'm going to do top minus bottom, and I'm going to get that minus that. All right, when I plug in 4 right here, I just get 4. When I plug in 4 right here, okay, guys, we need to remember how to do 4 to the 3/2. And this is something you got to just be able to do without a calculator, okay? Okay, check it out. I'll write it over here. All right, 4 to the 3/2. That halves on the bottom means square root, and then that 3 means to the 3rd. Now, it doesn't matter which you do first, but it's easier to square root and then cube. The square root of 4 is 2. 2 to the 3rd is 8. Okay? So when I plug 4 in there, that's 8, and 20 times 8 is 160. All right? Okay. All right, next, when I plug in 1, I get 1. And then 1 to the 3/2, I mean, same deal. It's the square root of 1 to the 3rd. The square root of 1 is 1. 1 to the 3rd is 1 times 20. Okay? I mean, this is slightly annoying. I'm going to try to keep the numbers pretty small on our test, so we're not like looking at all this. But anyways, what's this? That's like, geez, negative 156. That's negative 156. That's negative 19. Okay? Minus a negative is plus, and I get, dude, 137, I want to say. So, like, 156 minus 19. I think it's, yeah, negative 137. Okay, negative 137 what? Like, what the heck did I just find? That's how many gallons that I lost between time 1 and 4. How much oil is in the tank at time 4? Okay, so I'm not quite ready to finish this as my answer yet. There's 500 gallons. I lost 137. How many are left in the tank? 500 minus 137 is going to be 63, I think, right? 400. Yeah, 363 gallons in the tank at time 4. All right. Just because of the calculations, that one was a little bit difficult, but hopefully you guys understand the process of like integrating the rate to be able to find how many gallons something happened there. Okay, awesome. Let's look at this next one. Okay, when you guys see Riemann questions, I mean, you should actually be pretty happy because they're, I don't know, I think they're pretty easy, especially with the tables, you know? Just try to be careful to not make any like weird mistakes or whatever. Okay, a left-hand Riemann sum, 3 rectangles. So the first rectangle has a base of 2, and since it's the left, I pick the number on the left. So that's 5. The next rectangle has a base of 2, and I pick the number on the left. That's 8. And then the last rectangle has a base of 2, and I pick the number on the left, which is 2. So that's 10 plus 16 plus 4. So my left-hand sum is 30, okay? Now for a right-hand sum, all right, the bases are the same. The base is still 2. It's just that this time I pick 8 because it's on the right of those two. The base is 2. This time I pick 2 for that one. And the base is 2, but I pick -1 for that one. So that gives me 16 plus 4 plus -2, which is 18. Okay? So one's clearly like an overestimation, one's like an underestimation. All right? Now, here's how trapezoidal works. Let's see. Remember that the formula for trapezoid is 1/2. All right, 1/2. And then it's base sum of the heights. The base is 2. The sum of the heights, so I'm going to do both of them, 5 plus 8. I can come back and figure out what that is in just a second, okay? My next one, 1/2. 1/2 is part of the formula. My base is 2. My height is 8 plus 2. My next one, 1/2, part of the formula. My base is 2. My height is 2 plus -1. Okay? Now, this one's kind of nice because on each of these, the 1/2 and the 2 will cancel out, right? So I basically have 13 plus 10 plus 1. So 23, which is probably like the closest of all of them. All right? And there's my trapezoidal sum. So Riemann sum's pretty good. Just as long as you remember the formula, it's pretty like easy to work through. All right. Average value. Whenever you guys see average value, immediately I want you to think 1 over b minus a integral from a to b. Okay, so like before I do anything else, I'm going to remember that that's average value. What's the average value for the part of the curve which is between, now usually gives me 2 points. This says between its x-intercepts. Ooh, that is so mean, but it's okay. I got this, all right? You guys, x-intercepts are when this equals 0. Like where is this going to equal 0? Or in other words, where it's going to cross the axis. Well, if I factor out an x from both of those, from this side I get x equals 0. From this side I get x equals 1. So its x-intercepts are 0 to 1. Okay? Those are the x-intercepts. All right, cool. So my average value is going to be 1 over b minus a, 1 minus 0, the integral from 0 to 1 of x minus x squared dx. All right. So in this case, I mean, the average value doesn't really do anything because it's just a 1 on the outside. All right, so that's fine. Let's go ahead and integrate this. Okay, this one goes to x squared over 2. All right. This one goes to x to the third over 3, which looks pretty awful, but luckily we're only going from 1 to 0, and that's like easy money, right? Because we're plugging in a 1, which is not too bad. I'm gonna like move this little buddy over. Whoops, hold on. Give me some more room. Okay, cool. So you guys, I'm gonna do more room than that. Okay, I'm going to do top minus bottom. When I plug in 1 here, I get 1 over 2. When I plug in 1 here, I get 1 over 3. Okay? When I plug in 0 here, I get 0, and 0 here, I get 0. So I just have to figure out what 1/2 minus 1/3 is. Shoot, if I get a common denominator of 6... 2 times 3 is 6, so that's 3. 3 times 2 is 6, so that's 2, so that's 1/6. And yay, this is multiple choice, so yay, we're good right here. So this is the answer to this is going to be letter D. All right. Hey, page 1, good job. Take a break if you need one. How long's it been? 15 minutes, not too shabby, okay? Cool. Let's move on to our next part. All right, guys, this is the fun part. At the end of each page, I'm going to go and check and make sure that I got all the answers right with the answer key from before, and I made a mistake. Did anybody find it? Check it out. Nope, not that one. That one. My friends, look. What's 13 plus 10 plus 1? Jeez, Mitchell. It's 24. That was my bad. Okay, 13 plus 10 plus 1 is 24. But let that be a lesson to you that when you're doing a calculus problem and you screw up like adding, it happens, man. All right, so try to be a little careful, but it happens. Okay, here we go. Let's look at page 2. This is one of the ones that we want to memorize, you guys. So it's basically this: e to the x is e to the x, but a to the x is a to the x over ln of a, okay? Pencil's being a little sketchy here. All right, so let's see. 5 to the x, the integral is going to be 5 to the x over ln of 5 plus c. Okay, that's it. We just want to kind of remember that. Remember that that's a thing. Okay, look at number 7. Do you guys see derivative integral? All right, derivative integral. That's our second fundamental theorem of calculus. That's where we say, oh, a derivative and an integral cancel each other out. The constant goes away, and I just put the x in here. So it's square root of 1 plus x squared. That's it, all right? Didn't do anything else. I mean, you know, if we had to do chain rule, we'd multiply by the derivative of x, but the derivative of x is just 1. Okay, so this is going to be letter E. All right, just plugging that in. Okay, now for number 8, this is actually doing an integral. And I mean, when I look at my answers, like here's the thing that's like a little bit confusing, but look, let's see what we could do with that. All right. Okay. So t is like t to the first. The square root of t is like t to the 1/2. And do you guys remember that when you're multiplying, you add the exponents? All right. So I add that. So 1 plus 1/2 is 1.5 or 3/2. So are we cool if I actually just change this problem to t to the 3/2? And then you guys know that when we want to integrate that, we bring that up, okay? We write it as, it's still in its integral form, t to the negative 3/2. And now I'm going to actually do the problem, okay? So I add 1 to that. T to the negative 1/2 over negative 1/2, all right? The last thing that you'll probably remember is instead of dividing by negative 1/2, I actually want to multiply by negative 2 over 1. Okay? So when I look at all these choices, there was not an ln in it, and it's going to be this one. Okay? Okay, awesome. Okay, the graph of the function to the right consists of 2 line segments and a semicircle. G is defined as the integral from 0 to x of f of t. What is the value of g of 5? Guys, we go like this. G of 5 means I plug in 5 for x. G of 5 is the integral from 0 to 5, f of t dt. This is f, okay? Integral from 0 to 5 means the area from 0 to 5. So I basically need to find this triangle and then this semicircle. Okay? All right. Nice. Let's do the triangle first. That's going to be 1/2. The base is 1. The height is 3. So that's 1.5. Okay, I'll do the half circle next. We know that the area of a circle is pi r squared. This is a half circle, so it's 1/2 pi r squared. And let's look at what the radius is. So the radius is like this, right? So can you guys see that the radius is 2? So it's 1/2 pi times 4, which is 2 pi. So this is 2 pi. Okay? And then all I got to do is just add those together. So it's 1.5 plus 2 pi. Here we go. Everything's above the axis, so it's all positive. Do that a little bit better. Okay, nice. Okay, now we have one of these property questions. Okay? Now, the thing that it's asking me to do is it's asking me to go 0 to 3. Okay, look, I have a 0 to 6 and a 6 to 3 for F. And I have a 3 to 0, oops, sorry about that, for G. Okay, so let's do G first, it's easier. I can flip that. And instead of -7, what does that change to? +7. So I'm like chilling with that. Okay, so now I got to go over to F, and I got to kind of use both of these to figure out what 0 to 3 is. Okay, but look, I'm going to do it down here. If 0 to 6 is 9, so this like whole thing is 9, and 3 to 6 is 5, what is this part that's left right here? So I kind of like draw it visually sometimes. I'm like, okay, if the whole area from 0 to 6 is 9, 3 to 6 is 5, then this little part has to be 4, okay? So the integral from 0 to 3 of f of x is 4. Now I could go over and do this because they're both an integral of 0 to 3. And so like it's literally as simple as going 1/2 times 4 minus 3 times 7. So that's 2 minus 21 is -19. So it's going to be B. All right. Cool. That one wasn't too bad. All right. Nice. Here we go. Yay, a table. All right. Water is flowing into the tank at a rate of R, where R is measured in gallons per minute. T is measured in minutes. Values of R are given in the table below. Use a, this is the really only word that I needed in that whole thing, trapezoidal sum with 3 intervals, indicated by the table to estimate the amount of water which entered the tank from 0 to 9. Okay, trapezoid number 1, base of 4, the heights are 9 and 6. Okay. Trapezoid number 2, remember trapezoids are always start with 1/2. That one's got a base of 3, and the 2 heights are 6 and 4. And then trapezoid number 3, it's a 2, okay, has a base of 2 and 4 plus 3. Okay? And so let's just figure out what these are. 2 goes into 4 2 times. 9 plus 6 is 15 times 2, so that trapezoid is 30. I don't want to go 2 into 3, but okay, 6 plus 4 is 10. 2 goes into 10 5 times. 3 times 5 is 15. And then 1/2 and 2 cancel. 4 plus 3 is 7. So this gives me 45, 46, 47, 48, 52. Okay. 52. I'm going to be like super careful with my adding now because I don't want to make another mistake. So I got 52 for that. All right. Okay. Cool. 12 and 13 are just standard integrals, so this is good. This is why we're not using a calculator on this test, because you could just plug them in. So stuff like this is going to be on the no calculator part of your AP test anyways. All right. This goes x to the 4th over 4 and crosses out. This goes x squared over 2. There's no plus c because I'm evaluating it 2 to 1. When I go to plug it in, okay, when I plug in 2 to the 4th, that's 16. 2 squared is 4. 3 times 4 is 12. And then when I plug in 1, 1 to the 4th is 1. 3 times 1 is 3. So I get 4 minus -2. So that's 4 plus 2, so that's 6. All right. Cool. Okay. All right, in order to integrate this, you guys remember we got to bring that up as x to the -3. So when I integrate it, if I add 1, it becomes x to negative 2 over negative 2. Now, like, that looks a little annoying to try to figure out what that is, the way that it's written. But you guys remember that I sometimes talk about how, like, I bring the constants out front. That's just a negative 2, but I can, like, still bring it out front. And then, just so I don't have to really deal with it right now. And then this, I can move back down. So if you move something up and you got to evaluate it, let's move it back down. Okay, and this will be x squared on the bottom. So the negative 2 went outside, and that went down to the bottom. Okay, so again, this is a constant. I'm going to leave it out. The negative can go wherever. Like, it's okay if it goes on the outside or the top or whatever. And then I need to do this. Okay. If I put 2 in just right here, that's going to give me 1 over 2 squared. If I put 1 in, that's going to give me 1 over 1. And then I got to do a little bit of fraction stuff, but I know that 1/4 minus 1, 1's 4/4. So 1/4 minus 4/4 is negative 3/4. That's negative 1/2 on the outside. So if I multiply it together, it's positive 3 over 8. Okay, positive 3 over 8. Nice, nice. All right. Ooh, this looks so confusing, right? Let's just see if we can interpret what the heck this is talking about. Okay, first thing, it says that the integral from 1 to 3 of f of x is 2.3. What does that mean? That means from here to here. Go ahead and shade this. That means that the area of that is 2.3. Okay? It says f prime is f, big F prime is little f. And then what's f of 3 minus big F of 0? Okay, let's translate this, you guys. If capital F prime is little f, another way of saying would be the integral of little f then would equal capital F, okay? So the integral of little f equals capital F, and if I'm going 3 to 0, that means the integral from 0 to 3. So basically, it's just saying if you know notation, all right, it's telling me that that area between 1 and 3 is 2.3. What is the area here to here, so 0 to 3? Well, I'm just adding on this little block right there, yeah? And that little block is base 1, height of 2, so that little block is 2. So then the full area is 4.3, okay? So again, it's like understanding that the integral of little f is the derivative of big F, or, you know, vice versa or whatever, kind of understanding those relationships. Okay, you see questions like this, number 15, all the time on the AP test. Is specifically designed to trick you. Let me show you guys something. This is not the same as this. Okay? It does not mean, oh, cool, I already know what 2 to 4 is, I'm just going to add 3 to it. It doesn't mean that, okay? That is not the same. Now, it is the same as this, okay? So I can split up the integral, but specifically because of these parentheses right here, I have to do the integral of the f, and I have to do the integral of the 3. All right? That makes sense. So you can't just say, well, look, this is 6, so 6 plus 3 is 9. Like, that would be really easy, but it doesn't work that way. Okay, so here's what we got to do. Okay, so this part is the integral from 2 to 4 of f of x. And then this part is the integral of 3. And it's also from 2 to 4. Okay? Now this, look, was given to me right over there. So beautiful. So that's 6. That was not given to me, but I could figure it out because you guys know how to integrate 3, right? The integral of 3 is 3x because I'm going backwards, right? So the integral of 3 is 3x. I'm evaluating from 4 to 2. If I do top minus bottom, this is going to give me 12 minus 6. So this integral right here is 6, okay? Now look, that integral is 6, that integral is 6. So altogether, it's going to be 12. All right, so just if it adds a number right here, just make sure you integrate that number also. All right. Let's look at number 16. Okay, f is a function defined by, you guys, this is a piecewise function. It's called a piecewise function. It means, anything less or anything between 0 and 1, I need to use that equation. Else means everything else, right? It means if it was like less than 0 or bigger than 1, so else means everything else. Now, I want to find the integral from 0 to 3 of f of x. Well, I kind of got to divide this up to two different things, okay? Because between 0 and 1, it equals that. So that's going to give me x squared plus 4, okay? Between everything else, so 0 to 1, so now to split this up, this would have to go 1 to 3. And from 1 to 3, I need to use this equation. Because that means, again, that means the else, everything else. Okay? So I got to do two integrals here. I got to do these by hand. That's fine. I'm going to go x to the third over 3 plus 4x from 1 to 0. Okay. Top minus bottom. 1 over 3 plus 4. 0 plus 0. So for this one, I get 4 1/3. Right now, I'm just going to call it 4 1/3. If I need to fix it later, I can, but 4 1/3. Okay. Now, on this next side, all right, the integral of 6 is 6x. The integral of x is x squared over 2. And then I'm going to do top minus bottom. That's 18 minus 9 over 2. And then this is 1 minus 1/2. Now, remember I was telling you guys, if you have fractions on both, here's what I like to do, okay? I'm going to keep this the same, make that minus 1 plus 1/2. I'm going to combine these together because -9 plus 1 is -8. So together, those give me -8 over 2, which is -4, okay? So this side is 18 -4 and -1, which is 13. Okay, now this is saying the value is a number between what and what? Okay, 13 plus 4 and a third. 13, 4 1/3 would be what? 17 1/3? 17 1/3. So, yeah, it's definitely going to be between here and here. All right. Okay. Next, actually, I'm going to move this up here to give me a little bit more room. Can I do this? Sure, there we go. All right, it gives more room for this next one. Okay. I know I didn't give you nice enough room on this. I'm very sorry. Next time I'll space it out more. All right, what is the average value for blah, 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 blah? Okay, average value, you guys. 1 over b minus a, integral from a to b of this whole dang thing. Okay? All right, first thing is, out front, I have a 1 over 2. Okay, I'm going to integrate this. That goes t to the 4th over 4, and that can reduce. So that's like t to the 4th over 2. That goes t to the 3rd over 3, which can reduce. So that's t to the 3rd. And then that goes 4t. All right? And I need to evaluate that -1 to +1. Okay, so look, Again, I'm going to let the 1/2 stay all the way outside. I'm going to deal with that at the very end. And then I'm going to do top minus bottom. So I got like a lot of different things to plug in here to try to figure out. Okay. Okay. All right. When I plug in 1, okay, so remember the 1/2, I'm just going to deal with that in a minute. When I plug in 1, I get 1 to the 4th over 2 minus 1 plus 4. Okay, when I plug in negative 1 to the 4th over 2, so that's 1 over 2, minus negative 1, so that's plus 1, minus 4. All right. Okay, I'm going to distribute this because I have fractions. So I'm going to turn that into minus 1/2, minus 1, plus 4. Okay. All in here, and let's see what happens. 1/2 minus 1/2 cancels out. So I have negative 1 plus 4, negative 1 plus 4. That's 3 plus 3, that's 6. Okay, cool. So that's 3, that's 3, that's 6. Half of 6 is 3. So my average value is going to be 3. All right. Okay, good, good, good. A trig question. Let's do a trig question. All right. Sorry. Okay. The integral of secant squared x. Oh, shoot. I almost missed a word. Average value. Average value. Okay. 1 over b minus a, the integral from a to b. Okay. Now remember, we kind of talked about this, but if it says 1 over pi over 4, a really easy way to write that, that's 4 over pi. All right? So 1 over pi over 4 is 4 over pi. The integral of secant squared is tangent, because the derivative of tangent is secant squared. So the integral of secant squared is tangent, and I'm evaluating this pi over 4 to 0. Okay? So this is a constant out front. I will go ahead and leave that out front. And then I got to do top minus bottom. So I really just need to know what the tangent of pi over 4 and the tangent of 0 is, okay? As always, we are going to go back to our trig chart. Here we go. All righty. Let me erase some of the stuff I've been writing on here. Okay, so there are two things that I needed to find here, all right? I needed to find tangent of pi over 4. Pi over 4, tangent is 1. Okay, the other thing that I needed to find is tangent of 0. Okay, this is angle 0, so I'm looking here. Now, on this chart though, you guys, it only gives you cosine and sine values. It doesn't give you tangent, okay? But if you remember that tangent is sine over cosine, the tangent of 0 would be the sine at that point over the cosine at that point. Sine is 0, cosine is 1. So 0 divided by 1 is 0, okay? So I've got tangent of pi over 4 is 1, tangent of 0 is 0. Let's go. All right. Where was I? Here we go. Okay. So when I go to plug this in, the tangent of pi over 4 was 1, the tangent of 0 was 0. So this just equals 4 over pi times 1. Okay? So that's just going to be 4 over pi. All right. Okay. 19. This one is a little interesting. All right. So you guys, when I see this, it definitely makes me think of the second fundamental theorem. It's just that there's no like derivative in front of the integral. I'm going to go ahead and do that, okay, because that'll help me a little bit here. I'm going to take the derivative of this, but if I take the derivative of that side, I should probably take the derivative of this side as well. All right. Now, All right, so look over here. The derivative of 5x to the third is 15x squared. The derivative of 40 is 0. Okay? So I know that that equals the integral. No. That equals, sorry. The derivative of an integral, which just plugs it in here, it's f of x. That's what f of x is. Okay? That's what f of x is. Now, remember that, you know, f of x, f of t, whatever, these are all like kind of dummy variables, okay? I'm going to take this, now that I have that, f of x is this, I'm going to go ahead and put it back in here. All right? So this is going to see it a little bit weird, but, okay, I figured this out. So what this statement is saying is that, okay, let's see here. 5x to the third plus 40 is the integral from a to x of f of x, or f of t dt. But I know that that's 15x squared. Okay, so let me take this out, and let me put 15, well, we can use letters t. All right? Now, when we take an integral, you guys, when I take an integral, I add 1 and divide by 1 right there. So that ends up being 5t to the third evaluated from x to a. Okay? Remember, x is a variable, a is a constant. So I integrated that. When I'm evaluating from x to a, so when I plug that in, that'll be 5x to the third. When I plug that in, that will be 5a to the third. And you guys, this is supposed to equal 5x to the third plus 40. Okay? Now, if you look at that for a second, all right, look, 5x to the third, 5x to the third, those are the same. So I can, like, I don't know, get rid of those on both sides, yeah? And get rid of that and that. So really, the thing that I need to solve is 40 has to equal negative 5a to the third. Well, if I divide by negative 5, 40 divided by negative 5 is negative 8. And then if I cube root that, if I cube root both sides to get a, you actually can take the cube root of negative 8, and it's negative 2. Okay? Is that not like the most annoying question? Like, that's very, very, very hard. Like, that is one that, like, not too many people are going to get that question. That is really hard. I have to, like, think about that for a minute, okay? All right. All right, nice. Let's look at number 20. Okay, so again, when I like see this, an x, t, dt, it kind of makes me think second fundamental theorem of calculus. All right, this is telling me to find g prime. G prime means derivative. So the derivative of that means I take the derivative of that, okay? And the derivative of an integral is, I made that a little too big. All right, we put this in here. So it's the cosine of 2x squared, but then times the derivative of 2x because of chain rule. All right, that's what g prime is. Okay, so I did the derivative. I did the thing where I replaced the 2x on the inside, and it's the whole thing squared. It's 2x squared. And then I multiplied by 2. Okay, now this is actually asking me to find something, though. It's asking me to find the derivative of the square root of pi. What on earth? Okay, so g prime of square root pi is the cosine of 2 square root of pi squared times 2. Can we just talk about this for a second? Okay, 2 squared is 4. Square root of pi squared is pi. 2 squared is 4. Square root of pi squared is pi. So I'm basically doing the cosine of 4 pi times 2. All right, so what the heck is the cosine of 4 pi? Well, back to Mr. Trig chart. All right, back to over here. And let's remember a couple of things real quick. Let me clean this up a bit. All right. Okay, so you guys know that this angle over here is 0, pi over 2, pi, 3 pi over 2, 2 pi. And then it just keeps going around, right? Now, every time I go around the circle, so I go around once, that's 2 pi. If I go around a second time, that's 4 pi. If I go around a third time, that's 6 pi. And if I only go around half a time, that's 1 pi, 2 pi. So then that's 3 pi, 4 pi, that's 5 pi, 6 pi. So that's kind of how that works. So it was asking me to find the cosine of 4 pi, which is this angle right here. Cosine is the x-coordinate. So the cosine of 4 pi is 1. So coming back to my problem here, the cosine of 4 pi is 1. 1 times 2 is 2. 1 times 2 is 2. We go. Oh, I like this question. Okay, interesting. All right. Consider the function f defined so that f of x plus 5 equals the integral from 2 to x of sine pi t over 4 dt. Well, all right. See, this looks like it's going to be really complicated, but it's actually kind of cool. Just kind of think about your steps. F of 2, right? Okay, this means, let me find f of 2 first. F of 2. I don't have to do anything with that. I just have to put in the 2, right? Plus 5 is the integral from 2 to 2. I'm plugging in for x, y'all. I'm plugging in for x. Boop, boop, boop. Sine of pi t over 4 dt. But look, what's the integral from 2 to 2 of anything? So the integral from 2 to 2 is 0. Now, does that mean f of 2 equals 0? Not necessarily, because look. So now this says f of 2, whatever f of 2 is, I don't know, plus 5 is 0. Which means f of 2 is negative 5. Let's go. All right, so I got part 1. That's fabulous. Okay, now I got to get f prime of 2. Okay, in order to do that, you guys don't mind, I'm going to move this out of my way for a minute. Okay, f prime means that I have to take the derivative of all of this stuff. The derivative of each part. I got to take the derivative of this whole thing. All right. First, what's the derivative of f of x? F prime of x. Okay? The derivative of f is f prime. What's the derivative of plus 5? That's a constant. That's 0. And then what's the derivative of an integral? Well, derivative of an integral cancels each other out. That goes in here. So it equals sine of pi x over 4. All right? So I used the second fundamental theorem. And then I went, okay, I want to find f prime of 2. F prime of 2 then should be sine of pi times 2 over 4. Okay, that can simplify and just give me pi over 2. So, back to my trig chart. You guys are going to have both these on your desk, right? What is the sine of pi over 2? Okay, you guys can see right here. The sine of pi over 2 is 1. All right. Okay, so I come back up here. So f prime of 2 is the sine of pi over 2, which is 1. So then my final answer, negative 5 plus 1, is negative 4. All right. Oof. This isn't even that hard. It's just that it's using different letters. Instead of little f and capital F, it's using F and G, and it's like, dude, what? Okay, but look, right here, if G prime of x is regular f of x, then look what I can do, you guys. Integral. So the integral of f is regular g. With me? If g prime is f, then the integral of f is regular g. which means the integral of f is regular g, but it's evaluated from 3 to 2. Okay? So that just means I plug in the top, g of 3, I plug in the bottom, g of 2. Okay, so this just equals, or what this means is it's g of 3 minus g of 2. That's like technically the first fundamental theorem of calculus, but it's like, it says you actually integrate the thing and then you do top minus bottom. Okay? Okay, nice. Let's keep going here. Let me look over the next ones real fast. Make sure I don't make any mistakes on the last page. Oh, guys, it's too late at night. I need to take a walk. I got another one wrong. Okay, I need to go clear my head. Can we go back to number 16 really quickly? Okay, check it out. On number 16, when I was plugging in, okay, 3 times 6 is 18, that's fine. 3 squared over 2 is 9 over 2. But when I was plugging in 1, this is my problem right here, you guys, and I plugged it into 6. What's 1 times 6, my friends? It's not 1, it's 6. Ugh. Okay, boom. So that was supposed to be 6 minus a half, which meant that that was a 6, which meant that that was a 6, which meant that that was an 8. Okay, so my 2 are 8 and 4 1/3, which is 12 1/3. Oh my goodness. So it's actually that one. Okay, so my bad. Sorry about that. So far, that's -2 for Mitchell, all right? But hey, that's all right, man. If you can go through something like this and only miss 2, that's not bad. Especially because it's late at night and my feet are cold. All right. That's all right, though. We persevere, my friends. Okay. Cool. All right, let's take a look at number 23. The graph of the function f is shown if g of x, so some other function g, is the integral from -4 to x, f of t dt, which are true. All right, this is tricky. I got to go back to definitions. Okay, check it out. G is increasing on 1 to 2. How can I tell? Well, the definition of that means G is increasing, means G prime is greater than 0. All right, I just got to go back to definitions. So is G prime greater than 0? Well, what is G prime? Well, let's look over here. G prime means I take the derivative of this. So G prime, and the derivative of an integral just makes f of x. So this statement that G prime is bigger than 0, another way to write that same statement is, well, is f of x bigger than 0 between 1 and 2? So let's look. F of x between 1 and 2, that's not bigger than 0, that's less than 0. So that is false. Okay, got to go back to definitions. G is decreasing on -4, -3. That means G prime, okay, so decreasing means that the derivative is less than 0. Okay, and as I got over here, because of the second fundamental theorem, the derivative of G is regular f. So looking here, is f less than 0 from -4 to -3? -4 to -3. Hey, sure enough, that is less than 0, so I'm cool. So that is true. Now, okay, this last part, now it just says, is G of 0 less than 0? So I don't have to do a G prime because it's not increasing, decreasing. It's just saying, what is G of 0? So come back up here. And you guys, what is G of 0? That means I'm going to put a 0 right there. So G of 0 is the integral from -4 to 0 of my function. Okay? So G of 0 is the integral from -4 to 0. Now, let's look at the integral from -4 to 0. What can you guys tell me about that integral? It's strictly below the axis, right? So these are both going to be negatives. That's all going to be negative. So is G of 0 a negative? Yes, because the integral from here to here is negative. That is true. So my answer is going to be 2 and 3. All right. All right. Nice. All right. All right. Finally, it's been so long since I've seen just a very straightforward integral question. Okay, here we go. That is x to the third over 3, which cancels out. That is x squared over 2. That is 3x plus c. Okay? Nice. X to the third minus x over 6. So that's going to be this one. That's good. Okay. All right. So same thing here. So we got a couple of integral questions here. Guys. Okay. Little on the tricky side, these two. Okay. Now for number 25, the fact that there is a squared out here means that I actually have to do something to this before I can actually integrate it. So look, I got to take x minus 1 over 2x. And I actually have to like square it so that I can take the integral of each part, you know? This is going to be a pain. You know what I'm going to do? I'm going to do my little box thing. I don't know. Sometimes when I'm foiling, I like to do this, especially if it's confusing me like this. And I'm making a particularly lot of mistakes tonight. Okay, that's x squared. Okay, what's that times that? That times that, the x's cancel out, and it's negative a half. That times that, the x's cancel out, that's negative a half. And then that times that is positive 1 over 2x times 2x is 4x squared. Okay? All right, full disclosure. I just had to go back and fix this whole problem. I'm recording over it again because I said that negative 1/2 plus negative 1/2 was negative 1/4. You guys, what am I even doing? Negative 1/2 plus negative 1/2 is negative 1. Eek. Okay. Oh my goodness. All right. So this is actually the integral of x squared, negative 1, and 1 over 4 plus x squared. Or sorry, 1 over 4x squared. I said that wrong. Okay? Don't be tempted to pick that. That is like what we got when we foiled it, but that is not the integral, right? I got to integrate this now. Okay. We know the integral of x squared, that's x to the third over 3. So you guys, like, so far, can I say it's not that? It's not that. All right. The integral of 1 is 1x. Not that. Okay. And then we got to integrate 1 over 4x squared. I really hate these problems with the none of these because otherwise I could have just picked that. But let's integrate 1 over 4x squared. Now, you guys, the 1/4 I can kind of take outside. And then this, we're going to integrate x to negative 2. So it becomes x to negative 1 over negative 1. So it's 1/4 x to the negative 1. Okay, so this is 1/4, and then x to negative 1, that comes down here, plus c. Do you see how mean this is? How crappy is this? It's so close to that, but they put the 4 in the wrong place. Ugh. The answer is actually none of these. Man, these are all old AP questions. Why are AP questions so tricky? It's like they literally want you to fail. Not really, but that one is very tricky. Okay. 26. It's not terrible. What I want you guys to remember is that when you have a single term on the bottom, I want you to break up the integral to do that. So it's going to be like 2x over 2x. And then to do that, 1 over 2x. Okay? And like simplify them both before you start. Well, 2x over 2x is just 1. And then that 1 over 2x is just like 1 over 2x. Okay? These both say dx. And I need to integrate that now. So the integral of 1 is x. That's cool. That's easy money. So I can say it's not that and it's not that. All right. Now this one, do you guys remember me telling you that whenever I have an x, just a single x on the bottom, it's an ln problem? What I'm remembering is this integral. That, okay, 1 over x dx is ln x. Here's my issue. There's a 2 right there. But do you guys remember that we are allowed to bring this 2 outside because it's a constant? I can actually just move it out here. So it's 1/2. The 2 can just stay there basically. And the integral of 1 over x is ln of x. Okay. So it's 1/2 ln of x. So that's going to be this one right here. All right. Nice. Okay, friends, we are almost done. Let me check this last page and see if I made any weird mistakes. Hang tight. Okay, here we go. Hey, another just normal integral, crazy. Okay, that's going to be x to the 3rd over 3. That's going to be x squared over 2. That's going to be x, and I'm evaluating 1 to -1. I'm going to do top minus bottom. Okay, so check it out. When I put 1 in, I get 1/3 minus 1/2 minus 1. Okay, don't stress out about the fractions yet. We'll stress out about them in a minute. No, don't stress out about these yet. Okay, that's going to be -1 over 3. Okay, now, geez, a negative squared is a positive, but then I put another negative on it. So that's a -1/2. And negative times negative is +1. Now, these all have like crazy denominators, okay? But look, remember what we can do is, all right, I'll leave these the same. And then I'm going to distribute that. So it's going to be +1/3 +1/2 -1, okay? And the reason that that helps me is because the 1/2 and the 1/2 go away. Right, so 1/3 plus 1/3 is 2/3. -1 and -1 is -2, but at least now that's like not as bad, right? So 2/3 and -2, I can make that 2 over 3 minus 6 over 3, which is -4 over 3. Okay? Okay, here's another question. Very similar to that other one we did, it just has endpoints, where it has a single term on the bottom. So I'm going to split this up. So I'm going to call that x and -1 over 3x, except for that's not x, that's 1. Sorry. Okay, 3x over 3x is 1, and then on the other side is -1 over 3x. Now, when I integrate both of these, the integral of 1 is x, okay? Since I have endpoints, I'll kind of put this all together. Here, you guys remember, look, I can take out this constant, and I can just integrate 1 over x, which is ln of x. All right, so I can take out the -1/3, and then the integral of 1 over x is ln of x. All right, from 2 to 1, let's do top minus bottom. Here we go. Okay, if I plug in 2, that's 2. And then that's 1/3 ln 2. And then that's 1. And then that's 1/3 ln 1. And remember that the thing I want you guys to remember with ln's, the big thing is ln of 1 is 0. So check me out. That's 0. That's really helpful because then it's 2 minus 1/3 ln of 2. And when I distribute that, that's -1. I could go ahead and combine the 2 and the -1 to just give me 1 minus 1/3 ln of 2. Okay, and that's going to be that 1 minus 1/3. Are we almost done with this dang thing? All right, that's what you guys are thinking right now, huh? Okay, just kidding. Here we go. Single term on the bottom. I got to do this. Okay. So that's going to be 2 over 2 square root x. And then I got to do this. X over 2 square root x. Now, before I actually integrate these, you guys, I definitely want to simplify them. But you see how I split it up? Okay. On this side, the 2's are going to cancel out. All right. So this just becomes 1 over square root x. On this side, see I have an x on the top and bottom. Okay, so I want you guys to remember something. Well, okay, so first of all, this 2, we've seen this on like a million problems. I'm moving that out because it's being a pain. Okay. Okay, side note, little algebra stuff over here. X over square root x. This is x to the first, right? A square root is x to the 1/2. And when I'm dividing, I subtract. 1 minus 1/2 is 1/2. Okay? So this actually becomes x to the 1/2. Now this, when I bring that up, right? If I bring that up, it was x to 1/2 on the bottom. It becomes x to the negative 1/2. Crazy, right? So that's x to the negative 1/2. That is like x to the first over x to the 1/2, which is x to the 1/2. Oh my goodness. Here we go. If I add 1 to this, it'll be x to the 1/2 times 2 over 1. Okay, this 1/2 just stays here. This is going to be, if I add 1 to this, x to the 3/2 times 2/3. Okay. Look, that cancels out. So here's what I've got. 2x to the 1/2. And then a third x to the 3/2. And I have to evaluate this now. 9 to 4. Holy cow. Okay. If I plug in 9, the square root of 9, okay, 1/2 means square root. The square root of 9 is 3. 2 times 3 is 6. If I plug in 9, okay, 9 to the 3/2. The square root of 9 is 3. 3 to the third is 27. A third of 27 is 9. Let's go. That wasn't too bad. All right, if I plug in 4, the square root of 4 is 2. 2 times 2 is 4. And if I plug in 4, oh gosh, let's see here. Okay, 4 to the 3/2. The square root of 4, the square root of 4 is 2. To the third is 8. And then 1/3, so that's 8/3. So that's not the best, but okay. All right. 6 plus 9, that's 15. I'm going to just distribute that. Minus 4 minus 8/3. 15 minus 4 is 11. Shoot. 11 is 33/3 minus 8/3. 8, 9, 10, 11, 12, 13, 5. That is 20. It's really killing me. 25? 25/3. Here we go. Okay. All right, not bad. Whew. Okay. And one more where I have a single term on the bottom. Guys, this one is not terrible. All right. If I'm losing you, take a break, go get a drink, come back. All right. Okay, so the first one is e to the negative x over e to the negative x. The second one is 1 over e to the negative x. So first of all, this first one, you guys, that's just 1. Something over itself, that's just 1. This is actually nice because when it comes up, it's just a regular e to the x. So this problem is actually a lot easier than the rest of them, okay? So I need to integrate 1. I need to integrate e to the x, which is e to the x. And I'm evaluating 1 to 0. All right, so top minus bottom, here we go. 1 plus e to the 1, 0 plus e to the 0. Okay, okay. So the other thing that I need you guys to remember, e to the 0 is 1. All right, e to the 0 is 1. So that turns into a 1. So here's what I got. Okay, 1 plus e minus 1. So 1 plus e minus 1 is just e. Very cool. There we go. Okay, 31. Wow, this is just going to make my head spin. This is cool. If fx is continuous on the interval a to b and c is between a to b, then this is equal to what? You guys, here's how it works. Those have to be the same, and then that goes a to b. That does not work. Okay, those have to be the same. That already doesn't work. Oh, I do see that there's a negative, though. So look, a to c plus, and then I would flip that, right? B to a. Those have to be the same. Nope, doesn't work. All right, those have to be the same. Ooh, that's looking good. But then it would equal c to a. That's not what I'm looking for. That doesn't work. Okay, I have another minus. So this is going to be a to b plus c to a. Those have to be the same, and they're not, so forget that. And then there's my last hope. All right, those have to be the same, which they are, and it needs to equal that to that, a to b. Bro. All right. So then I'm like, shoot, none of them worked. Okay, so then what I'm going to do, since these were all plus anyways, I can flip this around. As an example, well, that one already did not work. That one did not match up. I could flip this around though, okay? And I can flip it to B to A to C, A's match up, B to C. But this one's C to B, so that's still not good. All right? This, it didn't match up. That was no good. That did not match up, so we're K. Okay, but look at this one. Look at letter D. It didn't match up this way, but let's say I flip these around. Because it's plus, I'm allowed to do that. C to A to B, match up, and it equals C to B, which is finally what I'm looking for. My goodness, it's going to be this one. All right. We'll think of maybe a better way that we can look at that. But there we go. That's your answer. All right. Ooh, last 3 questions. Oh, this is another property question. Let's see which of these properties are true. Okay, let's talk about these one at a time. This is actually a pretty decent little review here. A is false. You guys, the reason is because it is top minus bottom, but when I integrate F, it has to be something else, like capital F, you know? So that's false because it's saying the integral of F is F, which isn't true. All right. Let's see. This one, A to B, B to A, makes a negative. I like it. That looks true. Let's just move on and let's see. Any integral is positive. That's not true. If I draw below the graph, it can be negative. So that's definitely false. It didn't tell me anything about it. So that's false. And then, okay, check this one out. Derivative of an integral, we plug that straight in. So what's wrong? It should just say f of x, not f prime of x. We don't take the derivative of that. We just plug it straight in. So that's false. Okay? So that's a good one, little good review. So the only one that's true is this one. All right. Okay, let's see here. I'm going to integrate that. That's x to the negative 2 over negative 2. Now remember I told you guys, anything that's a constant, like I'm bringing this out. Because, you know. Okay, x to the negative 2 can go back down on the bottom. I'll just put a 1 on the top, and this is going 2 to 1. So My constant I'm going to leave on the outside. And then I'm going to do top minus bottom. This problem looks so familiar. Did we do this already, or am I just losing my mind? Okay, 1/4 minus 1 is negative 3/4 times negative 1/2. It's going to be positive 3/8. I swear we did that problem already. Okay. All right, or maybe I did it in another lifetime, which feels like this has taken a lifetime. All right, last one. Oh, let k be a constant. Okay, let's integrate this. Here we go. All right, x to the 4th over 4. That reduces, so it's x to the 4th over 2. X to the 3rd over 3. Okay, the integral of 2k. Now remember, 2k is a constant. K is a constant, so it's just a number. So that's 2kx. I'm evaluating 2 to 0. Top minus bottom. Okay, I am plugging these in for the x's, not the k's. The x's. So that gives me 2 to the 4th is 16 over 2. That's 8. That gives me, oh gosh. Okay. K times 2 to the 3rd is 8/3. And that gives me 2 times 2, 4k. All right. When I plug in 0, thank goodness, it's 0, 0, 0. And this needs to equal 12. So let's see what I got here. 8 minus 8k over 3 plus 4k equals 12. All right, I'm just going to like algebra this thing to death. So here we go. That's going to equal 4. Let me get a common denominator here. 4 is 12/3. Negative 8/3 plus 12/3 is 4/3 k equals 4 multiplied by the reciprocal. Boom, boom. K equals 3. Ugh. All right, let's make sure everything's right on this page. Hallelujah, my friends. We did it. All right, look, try not to stress too much. Reviews are harder than the test. It's got to be, because you wouldn't want a test that's harder than the review, right? So just, keep into idea the concepts and stuff that we talked about tonight. But you guys are good. All right, cool. See you later.